everyone. So for this second practice problem, we want to select the following functions for which the extreme value theorem guarantees the existence of an absolute maximum or minimum. And in order for the extreme value to guarantee this, the function needs to be continuous over a closed interval. And just a quick look down the list, we can see that all the intervals are closed intervals. So what we want to do is make sure that every value within that closed interval is in the domain of the function. So looking at this first function here, we have a natural log of 1 minus x. And with logarithmic functions, you cannot have a negative value as an input value for the log. So I can see right now that if I have a value of 1 or higher, that this is not going to be defined. So for example, the natural log of 1 minus, if I pick a value in here of 1.5, that's going to be the natural log of negative 0.5, that's undefined. Which means that this function is not continuous over this closed interval. So f of x is not an option. Now for g of x, we have the same natural log function, except for now it's 1 plus x. And since our entire interval here is positive, and 0, but even with 0, I have the natural log of 1. So this entire argument within the natural log function is going to be positive, which means that this is going to be continuous over the interval from 0 to 2. So that is one option. For the next function, we want to make sure that we don't have any values underneath a radical, a square root function, that are negative. We can have 0 underneath a square root function, so this endpoint of 1 is fine. It'll give us the square root of 0, which is okay. And then anything above 1 all the way to 4 is going to give us a positive value within that square root function. So this square root function will be continuous, and we have a closed interval. For this last k of x function, we have a square root function again, so we want to make sure that everything underneath that square root is positive, but it's in the denominator, so we also cannot have 0 in a denominator. So looking at that endpoint of 1, we would have 1 over the square root of 1 minus 1, giving us 1 over the square root of 0, which is 1 over 0, and therefore this function is not continuous everywhere within the closed interval, specifically not at 1. So this is not an option. So our answers are g of x and h of x.